My name is Sam Hubbard. I'm talking about Chinese culture and how it pushed industrialization and how that industrialization has released both ammonia and sulfur dioxide. The first thing I want to talk about, I did an interview with our school management teacher, and there is a clear point in Chinese history where they go through a shift that puts them from the old China, where they were a farming-based society, into this industrial powerhouse that we have today. And that is when Mao Zedong dies in 1976 and Deng Xiaoping opens up the borders of China and lets them see what's happening in the rest of the world. Prior to this opening of China, the people of China were pretty happy with what they had. They didn't have very much food. Their living conditions weren't great by our standards, but they were happy because they didn't know anything else. And then once they were opened to the world, they wanted what the rest of the world had, and that pushed them towards the industrialized nation that they are today. Now, the issue that I'm looking at is there's a planned release on the Washington Post from an interview with a former Chinese government official that plans to cut haze pollution by removing ammonia, but that could increase acid rain if a part of the proposal also isn't observed. The issue is if you remove ammonia, you have a problem with sulfur dioxide in the atmosphere, and as most of us, I assume, know, the Chinese aren't very forthcoming with what's going on in the government, so it's hard to have an official report from China whether or not they are observing this problem, because this report is from a former government official who no longer lives in China. In the past few decades, there has been an increase in air pollution and acid rain in China, and to combat this, the government has put forward proposals to reduce ammonia pollution from factories that produce it, to reduce ammonia and nitrogen oxide production by 15% by 2020, and they are funding significant research into agricultural ammonia reduction plans. To better evaluate the possible ramifications, the Chinese team used a chemical transport model. A chemical transport model is a type of computer numerical model which typically simulates atmospheric chemistry and may give air pollution predictions, alongside nationwide air measurements and a sophisticated ammonia emission model to predict effects of lower ammonia pollution. They found that haze pollution would be reduced by 11 to 17% if there was a 50% reduction in ammonia with improved agricultural management. However, the model also revealed that reduced levels of ammonia could reduce the pH of rain by up to 1 unit. Now that's really bad. There's a lot of delicate ecosystems that are still alive in China that changing the pH of the rain by 1 would kill entirely. And the team concluded that while it was possible to reduce ammonia emissions significantly, any economic benefit of the plan would be partially offset by the increased frequency of acid rain. Instead, the researchers suggest that a better approach would be a region-specific strategy that examines multi-pollutant controls. Now, the causes of Chinese ammonia pollution, there are these massive factories in China that either produce ammonia as a byproduct or produce ammonia in terms of fertilizer, and some of that ammonia goes off in the atmosphere. Again, these are tied in with, none of these numbers are official. These are all based on data from the Shanghai Stock Exchange that was found during a gas shortage in China because their productions, the Chinese government outlawed the bioproduction of ammonia or the objective production of ammonia during this gas shortage because there wasn't gas to produce, because it took too much fossil fuel to produce. So they saw these companies take this much hit to their ammonia production, and that's how we know these numbers, and these are both from 2003, I believe. No, the first one's from 2017, the second one is from 2003. The Yunnan province is in southern China, and the Jilin Chemical Group Corporation is in northern China along the border with North Korea. So it's happening all over China, this unsafe production of ammonia in the atmosphere. As the largest industrializing country, China has been changing rapidly over the last 3 decades, and its economic expansion is largely driven by the use of fossil fuels, which leads to a dramatic increase in emissions of both ambient air pollution and greenhouse gases. China is now facing the worst air pollution problem in the world and is also the largest emitter of carbon dioxide. A number of epidemiological studies on air pollution and population health have been conducted in China using time series case crossover, cross-sectional, cohort, panel, or intervention designs, which are all different methods that measure pollution and population health within a country. The increased health risks observed among the Chinese population are somewhat lower in magnitude per amount of pollution than the risks found in developed countries, which might mean that Chinese have almost developed some kind of resistance to this air pollution. Like this pollution has changed who they are as humans, that their lungs can handle more of this ammonia sulfur dioxide pollution. However, the importance of these health risks is greater than that in North America or Europe because the air pollution is so great. As the Chinese amount of air pollution accounts for more than a quarter of the world's total. There is increasing evidence that mounting climate change has already affected human health directly and indirectly in China, including mortality from extreme weather events, changes in air and water quality, and changes in the ecology of infectious diseases. One example of it happening not in China but very close to China is a tsunami that hit Japan and a nuclear reactor. While the nuclear reactor has killed more than the tsunami has, it's possibly a result of global warming. If China acts to reduce the combustion of fossil fuels and resultant air pollution, it will reap not only the benefits associated with improvement of air quality, but also reduce greenhouse gas emissions. Consideration of the health impact of air pollution and climate change can help the Chinese government move towards a more sustainable development with appropriate urgency. Now, a good deal of progress has been made in China since the mid-1990s with emissions of sulfur dioxide and particulate matter. Particulate matter is matter that is large enough to get through your body's filtering system, or small enough to get through the body's filtering system, but large enough that it stays in your lungs once it's there, and decreasing as a result of stricter enforcement standards. However, because of the increase in vehicular emissions and prevalence of fine particles, the government passed an amendment in 2000 to the 1987 Law of Air Pollution Prevention and Control. The new legislation calls for the regulation of transportation as well as residential commercial energy use. This is an example of where the Chinese government is forthcoming with information because it's official and they have enforced it. The issue with the one earlier is that it's not yet official. That article is as of December 2018, so it's very recent and it's probably still a plan that's in consideration there. In October of 2003, the Chinese Academy of Sciences, Chinese Academy of Engineering, and National Academy of Engineering, National Research Council of Academies held a symposium of experts from around the world to discuss China's challenges in developing an energy policy to address these issues, as well as to identify key trends that might influence future energy choices in China. The development of energy policy in China is important not only domestically but internationally, since China is increasingly competing with the United States and others for limited fossil fuel resources, and the resultant air emissions from fossil fuel combustion have a global impact. Now, the effects of ammonia being released by these industrial complexes in China, the main problem of ammonia released in the air is an unpleasant odor, which is detectable even at low concentrations. It is at particularly high concentrations, it's harmful to plant life. It's actually essential in low concentrations to plant life because plants need it. It's what's in fertilizer, but at high concentrations, it reacts too much with the water and is damaging to the plant, which is why also it becomes very serious when it's in bodies of water because it's highly toxic to aquatic organisms. Even low concentrations are very unsafe for aquatic organisms, and over-fertilization can lead to this seeping into the water and being harmful for plant and animal life. In China, you already see places like in Shanghai and around Shanghai, most of their former ecosystems that were there and even their wetlands are completely destroyed from pollution, a lot of which is ammonia pollution that went into the water and killed off everything that lived there, because if ammonia reacts with the water, then anything that needs the water to live doesn't want the ammonia to live. The ammonia sulfur dioxide reaction is studied using thermogravimetric analysis. It's a method in which the mass of a sample is measured over time as the temperature changes. And what was found with that reaction is that in our atmosphere, it is a lot easier to react ammonia with sulfur dioxide and water, because as you go higher in the atmosphere, your concentration of oxygen goes down, and as your concentration of oxygen decreases, the speed of the reaction increases, which is why there's not as much acid rain as there could be, and why there is a danger of removing ammonia from the atmosphere. And to understand the sulfur recovery behavior during the regeneration of SO2 absorbed sorbents and NH3, the temperature range of 10 degrees Celsius to 80 degrees Celsius is an optimal range for reacting. It is the range in which it can react. Optimally, it's at lower temperatures. Elemental analysis was another method used to analyze how fast and how much of the reaction occurred. Elemental analysis is a process where which a sample of some material is analyzed for its elemental and isotopic properties. Also, a method called wet chemistry was used to analyze this. And wet chemistry is a form of analytical chemistry that uses traditional methods such as observation to analyze materials. It is called wet chemistry because it's often done in water, or it's also called bench chemistry as it's also often done at a lab bench. The results show from all of them that the reaction is very fast and products are a mixture of various types of ammonium sulfites. That is ammonium sulfite as the main component. At lower temperatures, there's a greater NH3SO2 ratio to them, which means that a lower NH3SO2 ratio, which means there's more of that NH3SO2 reacted because it's an equilibrium reaction. I couldn't get the equilibrium arrow, so it's an equal sign to show that there's a balance between them in the atmosphere. But at lower temperatures, it favors the ammonium sulfite side, which means there is more ammonium sulfite than there is ammonia and sulfur dioxide separately. Now, if you remove ammonia from the atmosphere, the biggest issue is the ammonia is acting as the neutralizing agent for SO2. And if you don't neutralize the SO2, you can have a reaction that leads to the creation of SO3, which is unsafe to breathe in, as that is something that can get stuck in your lungs. SO2 itself can't, but a reaction with SO3, with oxygen, make SO3, it can. And it can also lead to acid rain because sulfur dioxide can react with water to create sulfuric acid, which is a very dangerous acid and can damage plant life at high concentrations because of this reaction. SO2 and other sulfur oxides are neutralized by ammonia, and that is what prevents the acid rain that's wrong on the slide. Exposure to it can harm the human respiratory system, specifically to children or those with asthma who have delicate, still growing respiratory systems. Now, this is important because as China is on its move away from an industrialized nation. Labor is costing more and more in China, and the Chinese population is becoming more educated. The world needs to learn from the mistakes that China had with this industrialization as they move to places like Vietnam and Cambodia and Southeast Asia, which is where the factories are moving. They need to take these things into account before the factories start to go up, and they need to put regulations in place before pollution can go in and push our world even closer to a climate change catastrophe. Thank you.